Differentiation of polynomials. Now when we'll do differentiation, the polynomial will be the default questions. You always have an x, always. So x will have multiple powers, negative power, positive power. So x is a variable. If you put 2x, 2 has no meaning in differentiation because 2 is a constant. X is a variable. So the differentiation will be done on x. So x differentiation is 1, x squared 2x, x cubed 3x squared, x4 4x cubed, xy 5x raised to the power 4, x raised to 6, 6x raised to the power 5. Now you see a pattern, and this pattern has come from the first principle, and that first principle says when you have y equals x raised to n, the differentiation, the derivative of dy by dx is n, x raised to the power n minus 1, n multiplied by x raised to the power n minus 1. This is your differentiation of a polynomial. Now, as I said, you will encounter various multipliers, and if they are constant, you don't have to worry about it. Dy by dx is always with respect to certain value. Here it is with respect to x. So you have to differentiate x. If you are not differentiating with respect to x, x will be treated as constant. You will learn that in the differential equations. So dy by dx, a raised x minus 1, a raised x to the power n, leave the a. For example, you have a y equals 2x to the power 4. So as I said, a is 2, constant is 2. You don't have to worry about 2, just keep 2. X raised n differentiation is nx raised to the power n minus 1. So here we have 4x raised to the power 4 minus 1, and that is going to be 8x raised to the power 3, and that is going to be the differentiation of this polynomial 2 into x raised to the power 4. Now there is a very peculiar case, constant value. For example, y equals 2, y equals c, y equals minus 5. Now if you go to the coordinate geometry, or you can say the Cartesian coordinate system, you will see that y equals c means a line which is parallel to the x-axis. You have a value c, which is y. So the distance of that line from the x-axis is c, constant. But it is parallel to x-axis, so there will be no angle. The angle of that line with the x-axis is 0. So the tan theta will be 0, dy by dx will be 0, m will be 0, slope will be 0, gradient of that line will be 0. So the gradient of this line, constant line, will always be 0. So differentiation of a constant value will be 0. So y equals to dy by dx of this constant value is 0. So you can assume that 2 into x multiplied by 0, x raised to the 0, x raised to 0 is always 1. Okay, anything to the power 0 is 1. So 0, x raised to power 0 minus 1, so you have a 0 here. That is how you can understand how this 0 comes. So y equals c, or any constant value, dy by dx is 0. Now we have the point. So there is a curve. There is a point minus 2 and 48. So you have to find out the gradient of the curve y equals 3x raised to the power 4. So essentially the question is asking find out the derivative of this value at minus 248. So in order to find out dy by dx, 3 is a constant. You don't have to worry about that. X raised to the power 4. 4 comes front. X raised to the power 4 minus 1. 3 into 4 is 12. X raised to the power 3. This is 12, x raised to the power 3 is the gradient, is the differentiation, is the derivative of 3x raised to the power 4. Now you have to choose the point minus 2 and 48. Just put minus 2 in place of x. What do you get? 12 into 2 into 2 into 2? Negative 2, because it is negative to the power 3. You get minus 8 into 12. That is going to be minus 96. Negative 96. This is how we find out the differentiation. Now we will not get these simple polynomial functions. We will get the combination of different terms in a polynomial function. For example, y equals x to the power 4, nx to the power n minus 1, 4 in front, x to the power 4 minus 1, that is 4 into x to the power 3. But here we have multiple terms, x raised to the power 4, 3x squared, minus negative 5x plus 2. So in order to differentiate the whole polynomial, we can take different terms one by one, differentiate them, and then combine them together. For example, x to the power 4 differentiation is 4x to the power 3. You have to follow n x raised to the power n minus 1 every time. Okay, 4x to the power 4 minus 1 is 4x to the power 3. What is 3x square? 3, don't worry about that. X square is 2x, so it becomes 6x. 2x raised to the power 2 minus 1 is 2x. 2x into 3 is 6x. Minus 5x, again x raised to the power 1 it is. So x raised to the power 1 is what? 1x to the power 1x to the power 1 minus 1. So you get minus 5 into 1, x raised to the power 0. Anything to the power 0 is 1. So you get negative 5 only. So the differentiation of x is 1. Please remember. And differentiation of a constant is 0. Right? So when you have the polynomial made up of sum or difference of a number of terms, the derivative will be made up of the derivative of each of the polynomial function, or you can say each of the term in the polynomial function. So if you have fx and gx, assume it to be two terms, x raised 4 and 3x square, fx gx. Just do the differentiation and combine them with respect to the sign. Sometimes, in some cases, there are different ways to do it. Okay, if you have this function, for example, 2x minus 3 and x raised to the power 2 minus 5. Now, the best way is to do what? Multiply it and solve it. But there is another way. If you assume one to be gx, the other to be px, what you can do is, you can do the differentiation of the first one, keep the second one like that, plus differentiation of the second function and first one like that, no change. So f dash x plus gx plus fx plus into g dash x, or in this case, first function differentiation, second function don't change, plus second function differentiation, first function don't change, add them. But the better way here is to multiply these two terms. When you multiply these two terms, you get different terms, and these terms can be differentiated individually and they can be combined in this way. So in order to find out the gradient of this function at the point -3, -36, you already have a f dash x. Just replace -3 in place of x and you are going to get the result like this. So f dash x is gradient, f dash x is the differentiation, f dash x the derivative, which is 62 here in case of -3. Most of the time there will be different kind of polynomial being presented to you. For example, you can have px by gx, qx by px, px by tx like form. Means numerator and denominator you will get. Right? So first we will do what? 3x raised to the power 5, 2x denominator, keep it below every term in the numerator and then solve it. This is a good way. But if you have an easy solution, what if you have polynomials, complicated polynomials? This is a simple differentiation. You already know it. N x to the power n minus 1 for x to the power n. Differentiation is like this. But you have a constant, leave it. So the other way of doing this is to differentiate the numerator multiplied by the denominator, subtraction of the denominator differentiation, multiplication of the numerator like that. So numerator, denominator you have to differentiate. Keep it like this. Numerator, denominator, numerator, just keep it like that. And then you subtract them and the denominator gx whole square you have to divide. So this is how you differentiate the polynomials of px by qx form or numerator denominator.